Hi everyone, welcome back to GMAT Maths Hub's YouTube channel. In today's video, we'll be covering some solved questions on the topic of properties of integers. Let's get started. So here's question number 1. What is the sum of the prime numbers that are greater than 50 but less than 60? So one important thing you need to memorize and need to be able to recall for GMAT or any other quant focused competitive exam is all the prime numbers which are less than 100. It's very important that you know all the prime numbers. So let me give you a quick refresher on that. So if you start with 2, 2 is the first and the smallest prime number, right? First of all, what are prime numbers? Prime numbers are numbers which have factors of 1 or itself. So if a number like, let's say q, the only two factors it will have will be 1 or q, correct? Those are all called prime numbers. And rest are all called composite numbers. And 2 is the first such number and is the only even prime number, right? So if you start with 2, the next number is 2, goes to 3, and then 5, 7, you have 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 77, 83, 89, and 97. So I'm able to recall this so quickly because I have a lot of practice recalling this. So I urge you to also practice recalling all the prime numbers. So now this question is asking us sum of the prime numbers that are greater than 50 but less than 60, right? So what are those? So greater than 50, we have 53 and we have 59, right? And nothing else. 61 is more than 60, right? So now what is the sum? You just need to sum these two, right? So 53 plus 59. That's going to give you 112. That's going to give you 112. And that is the answer for this question is 112. Great. Let's go to the next question. What is the product of the 4 smallest prime numbers? Right. So as you can recall, if you start with the smallest prime number, which is 2, 2, 3, 5, and 7. And after you have 11, 13, and so on. So, but you need only the 4 smallest, right? So 4 smallest. And we need the product. So product would be 2 times, 3 times, 5 times 7. So what's the easiest way to product this, right? So you just need to multiply 5 into 2, so you get a 10. And multiply 7 to you get a 21. So easiest way is 21 times 10. So that's going to be 210. Correct? Then that is your answer. Let's go to the next question. 3 consecutive numbers add up to 36. 3 consecutive numbers add up to 36. What is the smallest number of the 3? Right. So that's the question. So anytime you get a question which involves having 2 consecutive numbers, 3 consecutive numbers, or even alternate numbers, odd numbers, even numbers, you always start by assuming a number. Let's say the 3 numbers are A, B, and C, correct? So you can do it in multiple ways. You can say that the smallest number is n. So since they are consecutive, that means B would be just 1 more than n, right? And C would be 1 more than B, which is n plus 1 or n plus 2, correct? So n plus 2. So 3 numbers would be n, n plus 1 and n plus 2. This is one way to do it. Or another way would be if you assume the intermediate number to be n, it makes the calculation slightly easier because this is 1 less than, A would be 1 less than B, right? So it could be n minus 1 and C would be 1 more than B, which is n plus 1. So if you do that, you can easily calculate because you get to cancel out the ones. It's just a little bit faster. So if you take these 3 to be the numbers and we are told that they add up to 36, right? So it means if you add these 3, you get 36. So that's going to be cancelled out and then you get 3n equals 36, which means n equals 36 by 3, which is 12. And we need the smallest integer. So the smallest integer would be, n is not the smallest integer, right? N is b, but n minus 1 is the smallest integer, which means 12 minus 1, 11 is the answer. So you might need to be careful there, but in this case, if you are taken it, you may not be falling into the trap that you might be answering the number as 12. But yeah, you have the trade-offs of easier calculations as well. Anyway, the answer is 11. Great. So let's go to question number 4. The question says, if A and B are even integers, what must be odd? So it means which of these options must be odd. So which is just what we learned in the previous video, right? How to understand whether something is even or not based on the operation. So let's take the first one. So A plus B minus 2. So the first thing is A and B are both even, right? A is even, B is even. So if you have an addition of 2 even numbers, what do we know? If you just need to take an example, right? So let's take 2 plus 4, you get 6. So any 2 additions of even numbers will always lead to an even number. So that means a plus b is also even, right? So a plus b gives you an even number. Even number minus 2. So 2 is also an even number. So what do you get when you subtract two even numbers? You also get an even number. So this one is even. So this is not the answer. And let's take the second option. Second option is a plus b. A plus b is obviously even, right? So a plus b minus 2 is even. So a plus b is obviously even. So that's also not the answer. What is a into b? A into b. So a is even, b is even. So a into b would obviously be even, because since a is even, they'll definitely have a factor which is 2, right? Any even number has a factor 2, even if it is 2. Correct. So b will also have a factor 2. That means this number will have 2 factors of 2. Right. So that's, in fact, 4 will be a factor. So that's also going to be even. Okay, what about this is also not the answer. What about 4? So 4 says a minus b. A minus b. So that's even minus even. Even minus even is again even. So that's also not the answer. So it's going to be it's going to be obviously option 5, but let's check that. So option 5 says a plus b minus 1. So this is adding two evens and then subtracting an odd number. Correct. So which means even plus even is even, and we need to subtract an odd. So even minus odd is, take an example. Whenever you're confused, take an example. So you take, let's say 4 is an even number minus 1 odd number. So you get a 3. 6 even number minus 3 odd number, you get a 3. So that's always going to be odd. So even minus odd is always going to be odd. And that is your answer, which is option 5. Great. Let's go to the next question. So here's the question number 5. What is the greatest prime factor of 3 power 7 into 5 power 8? Greatest prime factor. So 3 to the power 7, what exactly do we mean by that? So it is 3 7 times, right? 4, 5, 6, 7. And 5 8 times. It doesn't really matter, but 3, 4, 5, 6, 7, and 8. And we're asked what is the greatest prime factor. So do you think, since first of all, let's refresh our understanding of what is a prime factor. So prime factor is any number which is a factor of a given number, let's say a number n, and let's say a is a prime factor of n. So a, first of all, has to be prime. Correct? And what do you mean by prime? Which means that a will not have any factor apart from itself, let's say a and 1. So apart from 1 and a, it should not have any other factor, right? Now let's look at this 3 power 7. So if you take 3 is a prime number, correct? So 3 is also a prime factor of this entire number. It's going to be dividing this entire number, because 3 power 7, obviously you can divide it by 3. You can divide 3 square as well, but if you take 3 square, what other number would be a factor of 3 square apart from 3 or 1, right? So it's always going to be 3 square. So any other number apart from 3 that you consider in this entire set, let's say which is 3 into 3 or 3 into 3 into 3, 3 power 3, 3 power 4, is always going to not be a prime number, because it will have more than one factor. And exactly the same case with this as well, except from 5. Apart from 5, you cannot have any other combination of 5s which will have a prime factor, which will be a prime factor. So that means apart from 3 and 5, you cannot have any other prime factor for this particular number, 3 power 7 times 5 power 8. So you have the contest only between 3 and 5. So between 3 and 5, which is the greatest one? So obviously 5. So 5 is the answer here. Hope you got that. Let's go to the next question. Okay, this is a PEMDAS related question. So let's solve it using the PEMDAS method. So refreshing our idea of PEMDAS. So PMDAS, right? So P is parenthesis, E is exponents, M is multiplication, D is division, addition, and subtraction. That is the order in which you need to perform any math operation, correct? From left to right. Now, if you take this question, you have a bunch of parentheses. So if you have a bunch of parentheses, it doesn't matter which you solve first, but all of them need to be solved before you move to the next operation, correct? So if you start with this, you have, this is 8 into 10 power 6, right? So that would be 8 with 6 zeros. 10 power 6 multiplied by any number will be extra 6 zeros, right? 1, 2, 3, 4, 5, 6. And then you have 5 times 10 power 4. So we are adding this. So let's just write down the numbers first and then we'll form the addition. So 5 times 10 power 4 would be 5, 1, 2, 3, 4 zeros. And then 3 times 10 power 3 would be 3 times 3 zeros. And then 4 times 10 power 2 would be 4 followed by 2 zeros. and this would be 6 followed by 1 0, and then 7 times 100 is 7, same as 4 times 10 square. It's similar to 4 times 10 square. Now we add all of these, right? Everything is an addition, hopefully, right? Yes. So everything is an addition, add all of this. So you would get 0, 6, 11, 4, 5, don't forget this 0, and write an 8, and that would be your answer. So which is going to be 8054160. Great. So that's all for today. Hope you liked the video. If you did like it, please hit the like button and do subscribe to our channel for more such interesting videos which will help you conquer the GMAT Focus Edition. Thank you and have a nice day.